Spinosaurus, whose name means spiny lizard, is an extinct genus of theropod dinosaur belonging to the Spinosauridae family. It lived from the early to middle Cretaceous, Cenomanian. However, some discoveries suggest that it may have inhabited the lower Campanian of the late Cretaceous in North Africa, in regions such as Morocco, Egypt, Tunisia, and Libya, between approximately 99 and 93.5 million years ago, or possibly up to 80 million years ago. The only confirmed species is Spinosaurus aegyptiacus, spiny lizard from Egypt, though there are indications of a possible second species, Spinosaurus maroccanus, based on a specimen found in Morocco. The first known fossils were discovered in Egypt by the German paleontologist Ernst Stromer in 1912 and described in 1915. However, the original remains were destroyed during a bombing raid in World War II in 1944. Fortunately, new material from other individuals has been found in the 21st century, although many fragments, such as jaws, are held in private collections, inaccessible to science. The contemporary Spinosaurid genus Sigilmassosaurus was considered by some authors to be a synonym of Spinosaurus aegyptiacus. However, recent studies have proposed that it is a distinct taxon based on the discovery of a new mid-cervical vertebra. Currently, the latest scientific publications do not synonymize the two genera. Spinosaurus is one of the largest known carnivorous dinosaurs, with recent estimates suggesting it measured between 13.6 and 15 meters, 44.6–49.2 thal, in length, and weighed between 7.3 and 8.5 tons. Its name refers to the large sail on its dorsal vertebrae. These estimates apply to specimens with more fragmented skulls and vertebrae, which may contain a margin of error due to individual variation and still unknown morphological changes. For specimens correctly attributed to Spinosaurus aegyptiacus, size estimates are between 10 and 11 meters, 32.8–36 cm in length, with a weight between 3 and 4 tons, though these numbers are associated with indeterminate growth stages. For example, the specimen F-Sac KK1AA88 is considered subadult, while BSP 1912 represents an unidentified growth stage due to the lack of studies before the remains were destroyed in World War II. 17 years later, in 2005, Dal Sasso and colleagues suggested that Spinosaurus had body proportions similar to those of Suchomimus, estimating its length between 16 and 18 meters, 52.5–59 fot, and its weight between 7 and 9 tons. This resulted in a titanic animal, as depicted in Jurassic Park 3 and Jurassic World, Camp Cretaceous. However, these estimates were criticized for the uncertainty surrounding the skull size and the scaling of Suchomimus, which was 11 meters, 36 feet long, and weighed 4.2 tons, to a size range that would give Spinosaurus an estimated mass between 12.9 and 18.4 tons. In 2007, François Terrien and Donald Henderson, using a scaling method based on skull length, challenged previous estimates, suggesting that the length of Spinosaurus had been overestimated and its weight underestimated. They calculated that the animal's body length was between 12.6 and 14.3 meters, 41.3 to 46.9 feet, with a mass between 13.2 and 23 tons. Currently, weight estimates for the largest Spinosaurus specimens range between 6 and 8.5 tons. Spinosaurus gives its name to the Spinosauridae family, which is divided into two subfamilies, Baryonychini and Spinosaurini. A study published in 2024, co-authored by Serino, revised his earlier calculations that had supported the idea that Spinosaurus was quadrupedal. However, these calculations had incorrectly shifted the dinosaur's center of mass to the front of the hips. The new study suggested that Spinosaurus fits better within the description of a graviportal biped, meaning a slow-moving animal, further invalidating previous theories that the dinosaur was quadrupedal or semi-quadrupedal. The debate over whether Spinosaurus was fully aquatic, terrestrial, or capable of switching between both habitats remains active today. The initial theory held that Spinosaurus was a semi-aquatic animal, and this conclusion emerged from fossil discoveries in 2014, which revealed highly distinctive anatomical features in this theropod. This was further supported by the discovery of a long and dense tail, suggesting that Spinosaurus could use this structure to swim against river currents. Studies conducted in 2018 by Ibrahim, Pierce, Lauder, and Serino showed that the dinosaur's tail was keeled and well adapted to propel it through water. On the other hand, an alternative view suggests that Spinosaurus was a predominantly terrestrial dinosaur. Research conducted in 2018 by paleontologist Donald Henderson challenged the idea of Spinosaurus as semi-aquatic. Henderson studied the buoyancy of crocodilian lungs and compared it with the pulmonary structure of Spinosaurus, concluding that the dinosaur could neither sink nor fully dive. His study also indicated that Spinosaurus could keep its head above water while floating, a behavior similar to that of other non-aquatic theropods. Furthermore, it was found that the dinosaur would need to continuously move its hind limbs to avoid tipping sideways, which is uncommon among semi-aquatic animals. However, the features of Spinosaurus's tail, with elongated neural spines on both its dorsal and ventral sides, suggest that it could swim in a way similar to modern crocodiles. Experiments conducted by Lauder and Pierce demonstrated that Spinosaurus's tail generated forward thrust 8 times greater than that of terrestrial theropods, such as Coelophysis and Allosaurus, and it was twice as efficient in producing movement. This suggests that Spinosaurus could spend long periods in water while hunting, much like modern alligators and crocodiles. Recent research completed in 2022 by Ibrahim and others analyzed the bone density of several theropods, concluding that Spinosaurus's bones were almost as dense as those of modern diving birds such as penguins. In penguins, this specific bone density is crucial for optimizing buoyancy during dives. The study included Spinosaurus and other spinosaurids in a broad database encompassing crocodilians, cetaceans, mosasaurs, ichthyosaurs, pinnipeds, and other aquatic groups. The researchers concluded that Spinosaurus, and possibly Baryonyx, fit the morphology of diving animals, with evidence suggesting that they may have fed underwater. Although the study was well received, some paleontologists, such as Donald M. Henderson, remain skeptical of its conclusions. In addition, a 2010 study directly analyzed the proportions of oxygen isotopes in spinosaurid bones, comparing the isotopic compositions found in the teeth of Baryonyx, Irritator, Siamosaurus, and Spinosaurus with those of contemporary theropods, turtles, and crocodilians. While there are counter-arguments regarding the use of the tail spines for propulsion and the aquatic behavior of Spinosaurus, a 2021 study suggested that speculations about the dinosaur's aquatic lifestyle were inconsistent or invalid. The features attributed to Spinosaurus point to a more terrestrial lifestyle, similar to that of wading birds like skuas, pelicans, shoebills, giant petrels, storks, or herons, rather than highly specialized aquatic or semi-aquatic animals like dolphins. A 2022 study was criticized by Donald M. Henderson, who stated, "I don't doubt that Spinosaurus had very dense bones, but would that be enough to help the animal sink?" Henderson, a paleontologist at the Royal Tyrrell Museum of Paleontology in Canada, whose 2018 study suggested that Spinosaurus was too buoyant, commented that he could not imagine how the dinosaur could remain submerged without extreme effort. He noted that when watching penguins swim, they quickly rise to the surface if they stop flapping their wings. Henderson questioned how Spinosaurus could stay underwater without significant effort. Not all animals with dense bones have aquatic or even partially aquatic lifestyles. For example, elephants and extinct sauropod dinosaurs possess dense leg bones to support their heavy weights. However, these graviportal structures are designed to bear weight, differing from the osteosclerotic structures found in diving birds like penguins. Extremely dense bones can provide animals with a unique advantage for remaining in water for extended periods without compromising their ability to move on land. Fabry also commented, "While a penguin or a crocodile can swim and dive underwater, they are also capable of walking on land." According to him, Spinosaurus and Baryonyx were more adapted to remain in water than other dinosaurs, but certainly came ashore at some point. For example, the first Baryonyx fossil contained fish scales and bones from a juvenile herbivorous dinosaur, indicating that this species was opportunistic both in water and on land. Tom Holtz, a Spinosaurid expert and paleontologist at the University of Maryland, who was not involved in the study, said that the new data might have implications beyond just Spinosaurus and baryonyx. The 2022 publication, in addition to receiving criticism from Henderson, was also criticized by Dr. David Hone. He remarked that the article brought nothing new, noting that previous studies, such as his 2021 co-authored research with Holtz, had already discussed how being in deeper waters or partially submerged, benefiting from bones with reduced pneumaticity and pachyostosis, could help spinosaurids hunt prey on the riverbed. Hone added that many points raised in his research were not mentioned, and several claims that had been tested or refuted with data were repeated. Hone also provided a detailed analysis in a documentary where he argued that spinosaurids were more comparable to modern wading birds than to semi-aquatic animals like crocodilians or hippos. He pointed out that the body structure of Spinosaurus was highly unsuitable for swimming, with nostrils positioned similarly to those of terrestrial animals, a dorsal sail that would impair swimming, and a tail resembling that of basilisk lizards and sailfish, poorly adapted for aquatic movement. In 2009, Dal Sasso and colleagues reported the results of CT scans of the snout from specimen MSNM Vi447. Since the external foramina connected with an internal space within the snout, the authors suggested that Spinosaurus had pressure receptors in its snout, used at the water's surface to detect swimming prey without seeing them, similar to modern crocodilians. Although this theory remains speculative, it still lacks additional confirmation in other publications. A 2013 study by Andrew R. Cuff and Emily J. Rayfield concluded that biomechanical data suggest that Spinosaurus was not an obligate piscivore, and that its diet was more related to individual size. The distinctive rostral morphology of Spinosaurus allowed its jaws to resist vertical flexion, but made them poorly adapted to withstand lateral flexion compared to other members of the Baryonychini group, such as baryonyx and modern crocodilians. Therefore, it is theorized that Spinosaurus may have hunted aquatic prey more frequently than terrestrial animals, though it was still considered a predator of land-based species. Using skeletal material from spinosaurids and crocodiles, they measured the alveolar area as a reference for tooth size to determine size heterodonty. They also conducted geometric morphometric analyses on the dental crowns and the skull regions supporting the teeth. Overall, spinosaurids had relatively large alveoli, and both spinosaurids and crocodilians exhibited isolated regions with enlarged alveoli. Additionally, spinosaurids had increased alveoli along the caudal dentary, a feature not present in baryonychines, which instead had several additional caudal tooth positions. Spinosaurines had a long concavity at the rear of their anterior dentary rosette, corresponding to a bulbous rostral dentary. Their feeding apparatus was specialized for quick strikes and deep punctures, but it was not efficient for cutting flesh or crushing bones. Their jaws interlocked tightly, allowing them to hold prey and push it further into the mouth. This suggests that spinosaurids were capable of handling large vertebrates, not limited to fish or smaller aquatic prey. Similar to crocodilians, spinosaurids had large alveoli and exhibited regions within large tooth sockets. The size heterodonty observed in these animals was positively allometric, meaning tooth size varied proportionally, much like in generalist crocodilians of similar size. In contrast, baryonychines showed limited oral processing, whereas spinosaurids had a greater ability to handle prey of various sizes. The purpose of the dorsal sail in Spinosaurus remains under debate. Several hypotheses have been proposed, including display, thermoregulation, and intimidation. The prominent sail could have made the animal appear larger, helping to ward off predators or intimidate rivals. If the sail had abundant blood vessels, Spinosaurus might have used it to absorb heat, suggesting it was only partially endothermic and lived in an environment with cool nights and clear skies. Alternatively, the sail may have facilitated heat dissipation, a common need among large animals whose surface area to volume ratio makes heat loss difficult. By increasing surface area without significantly impacting body volume, the sail could have helped the dinosaur cool off in the warm Cretaceous climate. In 1997, Jack Bailey proposed an alternative theory, suggesting that rather than a sail, Spinosaurus and other dinosaurs with elongated neural spines might have had fatty humps. These structures could have stored energy and insulated the body from heat, serving as an adaptation for both food scarcity and hot climates. Another possibility is that the sail had a reproductive function, playing a role in courtship displays, similar to a peacock's tail. Ernst Stromer, who first discovered Spinosaurus, suggested that the size of the neural spines could have varied between males and females, indicating sexual dimorphism. In 2015, Gimsa and colleagues proposed a hydrodynamic function for the sail, comparing it to the dorsal fin of a sailfish. They noted that more primitive spinosaurids with longer legs had rounded or crescent-shaped sails, whereas the sail of Spinosaurus was rectangular, resembling that of a sailfish. According to their hypothesis, Spinosaurus may have used its sail to reduce lateral drag in water, aiding in maneuverability. Additionally, the dinosaur's long tail might have been used to stun prey, akin to the hunting strategy of a thresher shark. Recent studies challenge the idea that Spinosaurus was a fully aquatic dinosaur, or an efficient swimmer. David Hone and Thomas Holtz argue that the dorsal sail would generate significant hydrodynamic drag and impair stability in water. They also highlight that the rigid torso and poorly muscled tail would hinder agile movement in aquatic environments. Unlike crocodilians, which have flexible bodies that allow them to make tight turns while pursuing prey, the morphology of Spinosaurus suggests it lacked such aquatic prowess. The structure of the sail is not fully preserved in any known specimen. Reconstructions by Ibrahim in 2014 and 2020 suggest a roughly square-shaped sail with a slight depression in the middle. This interpretation is based on the specimen FSAC-KK11888, which has one complete anterior neural spine, with several others being incomplete, and the posterior portion of the sail remains unknown. Scott Hartman proposed that the sail might have had a more rounded shape or a notch at the rear, based on his speculative reconstruction. FSAC-KK 11888, a fragmentary subadult specimen recovered from the Kem beds, described by Ibrahim et al., 2014, and designated as a neotype, though this designation was rejected by Evers et al., 2015. It is estimated to have measured between 10 and 11.4 meters in length, with a dorsal height of 3.6 meters and a weight between 3 and 4 tons. MSNMV 6894, possibly a juvenile, though its growth stage is uncertain. BSP 1912 August 19th, the holotype consisting of a left dentary, part of the sail, vertebrae, and ribs. Its length is estimated to exceed 10 meters. MNHN SAM 124, a fossil housed at the National Museum of Natural History, France, containing a partial snout with premaxilli, maxillae, and vomers. MSNMV 4047, recovered from the Kem deposits and stored at the Natural History Museum of Milan. This specimen, described by Dal Sasso et al., 2005, consists of a rostrum with partial premaxillae and maxillae, measuring 98.8 centimeters in length. Estimates for this individual range from 13 to 14.7 meters, possibly reaching 15 meters, with a total height of up to 5 meters and a weight between 8.3 and 9 tons. NMC 41852/42852, represented by an incomplete humerus, previously assigned to a potential Rebbachosaur or Spinosaurid. Comparisons suggest an affinity with Limosaurus, although this identification is not definitive. Ibrahim et al., 2014, maintain that it belongs to a Spinosaurid. HMUC R 16421, a dentary attributed to Spinosaurus cf. Egyptiacus, possibly the largest known specimen. It differs from the holotype in alveolar count, which may be explained by ontogenetic or individual variation. The descriptions of these specimens highlight the complexity involved in reconstructing Spinosaurus and understanding its adaptations. While the evidence suggests a preference for aquatic environments, its anatomical limitations indicate it was not as agile a swimmer as crocodilians. Furthermore, uncertainties surrounding the exact function of the sail and the variation among specimens add further complexity to this ongoing discussion. Estimates based on fossils suggest that this fully grown specimen reached over 15 meters in length and probably weighed more than 7 tons. However, It is important to note that our understanding of the Spinosaurus's maximum size is still evolving as new fossils are discovered and analyzed. This specimen is a true giant, measuring 15.5 to 16.6 meters in length, 2.7 meters at the hips, 4.8 meters at the back, 5.2 meters tall, and weighing 10.3 to 11 tons. A colossal animal. Spinosaurus inhabited swamps and flooded areas of North Africa, specifically within the Kem beds. This ecosystem is still being studied and remains partially understood. We know that Spinosaurus shared its environment with other large theropods, such as a large yet undescribed abelosaurid, the enigmatic Bahariosaurus, Deltadromeus, Carcharodontosaurus, and other spinosaurids like Ceratoseuchops, Riparovenator, and possibly Sigilmassosaurus. In addition, it coexisted with smaller theropods, such as an undescribed Dromaeosaurid and Rugops. This environment also hosted large sauropods such as Paralitidan. In its waters, there were giant fish and marine reptiles like plesiosaurs, along with several species of crocodiliforms. Hey folks, we've reached the end of our journey through the fascinating world of Spinosaurus, which ruled the lands of North Africa during the Cretaceous. With its incredible adaptations and massive size, it remains one of the most intriguing dinosaurs ever to exist. If you enjoyed the video, don't forget to leave a like and subscribe to the channel for more content about the age of dinosaurs and other amazing topics. Share your thoughts in the comments. What do you think about the new theories on Spinosaurus? Was it a generalist predator or a specialized aquatic hunter? See you in the next video. Until then, keep exploring the past and marveling at nature.